All right, back to chapter 3. And we reach here. So this is the graphical way of finding the resultant of few vectors, like 2 or more. There is also one way called, this is tip to tail. I always say tip to tail, I do mistake, but it's tail to tip. You will review this method. This is the name of the method, okay? And I know all the students نظرية الرأس والديل كلهم كانوا يقولوا لي بنعرفها. So you will review it. I know maybe you forget it somehow, but you will review it, and it's very important. And the other, my favorite, is the parallelogram method. And why it's my favorite? شو معنى parallelogram? Parallelogram means متوازي مستطيلات, okay? أو متوازي أضلاع. متوازي أضلاع, sorry, متوازي أضلاع. You can Google it, what it means, even though the picture is very clear for what is the meaning of parallelogram from the word parallel, okay? And most of the students, when they have two vectors, they do this mistake, and now you hear my record now, and after you study the two methods, you come back to my record, and so that you will come to know that, you know, why I am mentioning these things, that this is the way to solve by parallelogram, not this way. This is the common mistake for solving resultant vector of two other vectors. But there is one problem with the parallelogram, that it's only valid when you have two vectors. But if you have three, it's not valid anymore. But you will see how many times we will be using parallelogram method, and it's very helpful. Okay, and range of vector lengths. This is conceptual question. So always the conceptual question and the exercise underneath, which you know now that the answer of this exercise will be at the end of the chapter, literally the last page of this. So this is exercise A. This is the answer of exercise A. So let me go back to the vectors. Look there. Good. So when we're done here also, whenever there is caution, you have to see it. I am just screaming with you very quickly what you will be going through maybe in the weekend, you know, whatever. Before coming to the next class, you need to screen and to know how to deal with vectors. Here, if we subtract, this is the section of subtracting vectors, and multiplication of vector. If you have two vectors and you want to subtract them, subtract mean you reverse the direction. It's not really, it's the same as addition but with reverse direction. You can see that. You need a couple of hours, by the way, guys, to go through them. Here, if we multiply a vector with a constant, how this will affect the size, and as well with the direction when we multiply it with negative. Great. Adding vectors by components. Now this is a bit more complicated, but seriously, I want you to go through them. If we have this vector that we've been mentioning in from the beginning of chapter 2, that it has an angle with x-axis or with y-axis. So each vector which is not originally on the x or the y-axis, it already have two components, x component and y component. And now once you see, by the way, you don't have to go through all that. If you see the picture and you understand what is going on, this is only to explain things for the students who maybe forgot what's going on. Here literally he's defining the sine, cosine, tan, which is opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So if you really know these things, no need to go through them. The most important that you see that what is sine theta? It's opposite divided by hypotenuse. It means if somebody will ask you what is the y component of the vector, you will say v times sine theta here. So you will see the shape, you will see how it's decomposed into two components, and how to express our components into the main vector itself times the sine or the cosine of the angle, depending on what you're dealing with, okay? And then again, the resultant vector will be calculated by the Pythagoras theorem between the x component, the y component. I know I am going very fast, and he's giving you a numerical example that you need to go through as well. So guys, it's a revision. Here adding vectors with components. It looks complicated, but really it's not. That now both vectors have components, so how to add them up. Now, inshallah, in the class, this is the physics example or the application. I will be doing this example. But you see, I'm not gonna go and explain vectors all over again. How, why, so and so. I will be solving, assuming that the students have gone through all these sections. Yani, this is section, the last section, what is the name of the last section? 4. It's all section 4 also, except the last small bit, which is the application, basically physics application. So please, students, please do yourself a favor and come prepared to the classroom, okay? I would really appreciate that, because you will make this class to go smooth, okay? And we can go very nicely and smoothly with the classroom. So please, guys, I would expect that you will come ready, reading everything, trying to recall everything from high school, and we will be doing, inshallah, example next class. Meet with you next week. Have a lovely weekend.